So the question asks, does the method appear to be effective? Well, we got a confidence interval between 0.857 and 0.943, or we could say 85.7% and 94.3%. So we are 99% confident that the true population proportion of baby girls born is between 85.7% and 94.3%. So usually it's about a 50-50% chance, but now it's gone up from a 50% chance to between 85 and 94% chance. So it looks like this method does appear to be effective. Okay, now if we're trying to determine the sample size, we've got two options. If p hat is known, we will use this formula here. So that would be a z-score squared times p hat times q hat divided by your margin of error squared. If p hat is unknown, we will use this formula here. So you still have a z-score squared, but since I don't know what p hat times q hat would be, we just assume it to be 0.25. And then we divide by the square of the margin of error. Okay. The important part is you need to round up to the next larger whole number if n comes out to a decimal. Okay. So use the given information to find the minimum sample size required to estimate a population proportion or percentage. And here's your info. Your margin of error is 0.7. Your confidence level is 95. P hat and Q hat are unknown. So since they are unknown, I need to use this second formula. Okay, so n is equal to z squared times 0.25, that's just part of the formula, divided by your margin of error squared. Okay, to get your z-score, that's going to come from your confidence level. If I've got a 95% confidence level, well then my critical value or my z-score will be 1.96. Okay, so 1.96 squared times 0.25 divided by 0.07 squared. This comes out to exactly 196. So your minimum sample that you need to have these requirements met, is 196. Okay? Many states are carefully considering steps that would help them collect sales tax on items purchased through the internet. How many randomly selected sales transactions must be surveyed to determine the percentage that transpired over the internet? Assume that we want to be 99% confident that the sample percentage is within 5 percentage points of the true percentage for all sales transactions. Okay, so we could read this right here. How many randomly selected sales transactions must be surveyed? That's basically saying find n, or your sample size. Okay, we want to be 99% confident that the sample percentage is within. Okay, this word right here, the within, that's actually a key word, And right after that word, the 5 percentage points, that's actually talking about the margin of error. So margin of error. And then it doesn't tell me anything about p hat or q hat. So I'm still going to be using this second formula right here. Okay, so n is equal to z squared times 0.25 divided by your margin of error squared. Now we're looking at a 99% confidence level. So that's going to be 99. My z value or my critical value is going to be 2.575. 2.575, that's squared, times 0.25 divided by, okay, they said 5 percentage points. We're going to change that to a decimal. So 0.05. 0.05 squared. This comes out to be 663.06. Because it came out to a decimal, we have to round up to the next larger whole number. So 664 would be my minimum sample size. Okay, and last one. Use the given data to find the minimum sample size required to estimate the population proportion or percentage, given these requirements right here. Margin of error is 3 percentage points. We're going to go ahead and change that to a decimal. We're looking at a 90% confidence level. That will give us a z-score. We'll go back to that table. Okay, so we're looking at 90%. So we'll have a critical value of 1.645. 1.645. Now this time they tell me what p hat is. It's 0.58. So since they tell me what p hat is known, therefore I have to use this first formula. Which also means I have to find what q hat is. So q hat will be 1 minus p hat, or 1 minus 0.54, or the same thing as 0.42. Okay, so n is z squared times p hat times q hat divided by our margin of error squared. So that's 1.645 squared times 0.58 times 0.42 divided by 0.03 squared. Now for this number I get 732.43. Again, because it's a decimal, comes out to a decimal, you got to round up to the next larger number. So 733 would be your final answer.